Mr. Wayne, what's up?
Hey,
Good to
it's a
see
new
you, man.
day. Used to have we have the same shirts on, but
New hat.
oh, I've kept my same hat.
Yeah. Day 23 without showering. Just joking. It's
This
2020.
isn't Survivor. Hey, this is our second to last video. So
Oh my God.
today we are going to learn about salt hydrolysis. If you've ever wondered if salts are acidic or basic or neutral, you're in the right spot.
I bet they've never wondered that at all.
And why is sodium chloride used on French fries?
Delicious. That's why.
Does it make them taste salty, or acidic or basic?
Acidic or basic. I like
Yeah.
that. Yeah. So hydrolysis, if you think about it, let's break down this word, man. So it means the breakdown. That's what lysis means, remember? And
Lysis.
that's the breakdown of salt using water. So remember when we would dissolve salts into water, they would break down into their ions or dissociate in their ions. So what we're gonna do is we're gonna take a salt and break it down into its ions. And then some salts are acidic, some salts are basic, and some salts are neutral. A lot of times we'll put, like, if you see those big white piles on farm fields, that's a basic salt, because when you grow corn, corn makes the soil acidic, and you can't grow stuff in acidic soil. So they put a basic salt down over the whole field, and it raises the pH back up to where it needs to be. So sometimes you need acidic salts in your soil, and sometimes you need basic salts in your soil. So that's what we're doing with today, right?
Some things can grow in acidic soil, but not corn. For example, down in North Carolina, they have a lot of pine trees, and there's a golf course down there called Pinehurst, and their soil is naturally a little bit more acidic down there, and that's why the pine trees thrive in that area. I learned that one time.
That's cool. That's a good
Yeah.
course too.
Oh, it's beautiful.
Man, when I grew up, that was the course. They used to play some U.S. Opens there, I think, or something, didn't they?
Yeah, Pinehurst number 2.
Yeah, that's awesome, man.
All right, let's get back to it.
Oh, what are we talking about? Okay, here we go. Salt hydrolysis. Okay, first let's review real quick, Mr. Wing. There's your strong acids, right?
Remember, you memorized these.
I did. I don't know if they did. And there's your strong bases. So if it's not in this list, we consider it to be a weak acid or a weak base, right? So as long as it's not in here, if you have any acid that starts with a hydrogen that's not on this list, it's considered a weak acid. If you have any base that's not in group 1 or group 2 metals, then it is not a strong base. Is that cool?
Yep, they should all have this written down at this point. That way it's easier you don't have to pull up the PowerPoint to check it.
They're probably thinking, why do we need to know that? Well, guess what?
Here you go.
Okay, so what we got first here is what we're calling our parent acids and bases here. And what we're talking about in this situation is we have some rules of how to figure out what the parent acids and bases are of salts. So I'm going to have to make us disappear here for a second, Mr. Wing. I'm sorry. There we go. So since salts are made up of Arrhenius acids and bases, their acidity level depends on the strength of each acid and base that makes them up. So think about it. So what I'm saying is that salts are made up of acids and bases that come together, neutralize, and make a salt. So let's talk about how each one comes in. Let's see what we got. So what we have is the metal of, let me see, I'll get us back in. No, that's a terrible idea. Hold on, Mr. Wing. Okay, so the metal of the salt comes from the base. Put it first with the hydroxide. So for example, if I had a salt that had sodium in it, okay, like sodium chloride, sodium fluoride, sodium nitrate, whatever. If I have sodium in there, I'm going to take that first part of the salt, sodium, and put it with hydroxide. That's now what I consider my parent base. All right. Now, Mr. Wing, is that a strong base or a weak base? What do you think?
Well, it's going to be a strong base because sodium is in group 1. So I know that any time a metal is with a hydroxide in group 1 or 2, it's going to be strong.
Beautiful. Okay. Now let's go ahead and talk about the second part of the salt. Okay. So the non-metal of the salt. All right. Let me show you here. The non-metal of the salt, it goes with the acid. So we're going to put it second with the hydrogen. So it was sodium chloride. Chloride is the non-metal of sodium chloride. We put that with the hydrogen, and then we make hydrochloric acid. Is that a strong acid or a weak acid, Mr. Wing?
Strong. And I know that because I just memorized it.
That's because you're a boss, right? So we have hydrochloric acid is a strong acid, and the sodium hydroxide is a strong base. That's going to come into play later. All right. So here's the rules. You ready?
I'm ready.
Here's the rules. Okay. So here we go. Strong acid, strong base, they neutralize each other out. We got a neutral salt. Okay. But what if it's a strong acid with a weak base? Boom. The strong acid is going to overtake the base. You now have an acidic salt in that situation. And finally, the opposite is true. If we have a weak acid and a strong base, boom, you're going to have a basic salt. The base overcomes the weak acid, right?
That's
and then if we
correct,
have a
sir.
weak acid and a weak base, we don't care about it in this class because it all depends on the Ka and the Kb, and it's beyond what we need to know. What do you say? We just ignore that.
Yep.
All right, let's do that. You ready to see some examples, Mr. Wing?
I'm ready.
All right, here we go. So let's see. We got this guy right here.
So
when they react, they're going to form an ion compound. Here's our salt right here. Look, I took this hydrochloric acid, this sodium hydroxide, and I made a salt and water. So how's this work? It's a double replacement reaction, Mr. Wing.
I love those.
I know. So this hydrogen is essentially going to replace this sodium, and they're going to switch places. The old wife swap, right? So
the old double date switcheroo.
What's it called? What do you call it?
The double date switcheroo.
I love it. All right. So this sodium is going to replace that hydrogen, and now the sodium is going to go with the chlorine. That's how we get sodium chloride. And the hydrogen always goes and replaces the sodium with the OH here, which makes water. Every time you look at it, you're going to make water in every single one of them, right? So it's just this first part of the base and the second part of the acid they're going to get together to make what we call the salt. All right. So let's talk about these. Ready? Is hydrochloric acid a strong acid or weak acid, Mr. Wayne?
Strong.
Strong acid. And what about sodium hydroxide?
Strong base.
Strong acid, strong base. We go back to our rules. What kind of salt they're going to be?
Neutral.
Oh, okay. So that's a neutral salt. So sodium chloride, the thing that you guys know as table salt, is considered to be a neutral salt. So it will not make your food any more acidic or any more basic. We love it. All right.
And if you were a farmer, if you put sodium chloride on your ground, it wouldn't change the pH.
No, but it would kill all your crops if you had enough of it. What about this sulfuric acid? Is that one of our strong ones?
Strong acid.
Oh, what about silver hydroxide?
Ooh, silver is a transition, so I don't think it's in group 1 or 2. So therefore, it's going to be weak.
There you go. So you got a strong acid, weak base. Strong acid, weak base. What's the salt going to be?
Acid.
That's going to be an acidic salt right there. So silver sulfate is an acidic salt. All right. Hopefully they can kind of see the pattern here. How about this guy? This is acetic acid vinegar. Is that a strong acid or weak acid?
Weak.
Weak. How about magnesium hydroxide? Strong base or weak base?
Magnesium's in group 2, so it's a strong base.
Oh, so we got a weak acid. We got a strong base. Strong base overcomes the weak acid. This salt's going to be what?
Basic.
Basic. Like you, Mr. Wing, you're basic. Aha. Good slam. So there's an example of each type of salt there, of how they worked and how they became their way.
So,
right?
so this is one way you can see it. And so that's basically the reverse reaction kind of, but now we're going to show you the second way to look at.
So what I want to know is, like, we can kind of say, hey, what kind of salt would be formed with these, which they're going to have to know on the next one, which is titrations, right?
Right.
You're going to have to know what kind of salt is formed. Is the salt going to be a neutral, acidic, or basic? You're going to have to see that on titrations. But what if I gave you a salt and dissolved it in water, right? You got to figure out whether that salt is acidic or basic. So let's go ahead and try this real quick. So here's sodium chloride, right? The way you do it is you take the first part of the salt and you put it with hydroxide, just like the rules told us. So you get sodium hydroxide there, and you take the second part of the salt and you put it with hydrogen, and that's why you get that acid right there. So the first part always goes with hydroxide. The second part always goes with hydrogen. And then all you got to do is compare these two and follow the rules, right?
That's right.
The sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. That means sodium chloride is a neutral salt. So they should know that that salt is neutral. All right. Ready for the next one?
Yep.
All right. You do this one, man.
Okay. So we have silver sulfate, and we're looking at the silver is going to go with the hydroxide. And that is a
There's only one silver there, man. There's two here.
Ooh. Oh well. It's going to be weak.
But like, isn't hydroxide, what's its charge on hydroxide?
-1.
Oh, and what's the charge on silver? +1.
+1.
That's why it's a 1-to-1 ratio, right?
So that works.
Yeah, because sulfate was a -2 and
Yep.
silver was a +1, so that's why you needed 2 of them here.
So we'd have to balance this equation, but we left the waters off on the other side anyway.
That's true.
So anyway, we have a weak base, and then I know that sulfuric acid is a strong acid. So therefore, this is going to be an acidic salt.
There you go. So notice this is a sulfate here, which has a -2 charge, which is why we needed 2 hydrogens there for the parent acid. So this is sulfuric acid with strong acid. This is silver hydroxide, which is a weak base. Strong acid, weak base, acidic salt, right?
So a lot of times, guys, we'll just give you the salt. We'll just give you that silver sulfate, and you'll have to write the weak or the basically the parent acid and the parent base. So we already have them kind of written for you, but that's why Mr. Worth is reminding you that you have to make sure that that compound is neutral as well, just like we did back in Unit 5.
A long time ago. Yeah, you wouldn't want to make this like Ag2OH because a lot of people are thinking, oh, there's 2 silvers over here, but 2 silvers over here. But you only need 1 silver because hydroxide is a -1. That's why you only need that. But you need 2 hydrogens over here to neutralize that SO4, which is a -2.
All right, one more example.
There we go. And we got Mg.
Magnesium acetate.
Right? Look at that, Mr. Wing. Why is there 2 hydroxides?
Well, because magnesium has a +2 charge.
There you go. So we got to make sure that's neutral. And then we have this one, HC2H3O2. So we basically took this acetate and put it with hydrogen. Notice there were 2 acetates before, but now there's only 1 acetate because hydrogen only has a +1, right? Yep. What about magnesium hydroxide? Strong acid or weak, or strong acid? Weak or strong base?
Strong.
Strong base. That's a group 2, right?
Yep. And then it's
weak or strong acid?
Weak.
Weak is not one of the ones we memorize. So if we have a strong base, weak acid, we got a basic salt, my friend. Okay. So this is a basic salt. This is an acidic salt, and this is a neutral salt. What do you think?
That's it, folks. Way less complicated than the pKa and ice charts from last time.
I mean, they'll still struggle with that a little bit, but they just got to practice. That's it, man. That's all it takes, a little practice. Make sure you guys know if you have any questions, email us. We're here for you anytime you need it. Mr. Wing, you got any other thing you need to add or anything?
Nope. See you tomorrow.
See you tomorrow, brother. Take care.